At sea, north of the Arctic Circle, the challenge: achieve a better understanding of factors that help drive the rapid loss of late summer sea ice.
The Arctic Ocean is very complex in the types, particularly the Beaufort Sea, the different types of water masses that are there and the different types of water.
Just if you guys, and we'll do the...
Oceanographer John Mickett of the Applied Physics Laboratory at the University of Washington spent September with colleagues from the Scripps Institution of Oceanography, cruising the Beaufort Sea, where ice losses have been dramatic. Scientists gathered data on how and where heat flows in Arctic waters and how that heat affects the ice cover.
We worked both in the ice and we worked in open water. And one of the things we're investigating there is would we see a big difference in that sub-mixed layer mixing, so the upper ocean mixing, in environments where we have maybe 80% ice coverage and in environments where there was no ice at all.
Investigators aboard the NSF research vessel Skuliak came equipped with tools developed at APL-UW. SWIMS, the shallow water integrated mapping system, is dragged behind the ship, generating fine-scale maps of water properties at different depths. And the Modular Microstructure Profiler, or MMP. With this device,
we can get fine-scale turbulence measurements from that. We can calculate heat fluxes, vertical heat fluxes. Looking at our MMP microstructure, we see very, very large heat fluxes just at the base of the mixed layer. It's maybe only 10, 15 meters down, but they are surprisingly large fluxes. And what's interesting about those is that it looks like they were driven by the wind acted on the surface of the ocean.
So wind energy may play a role in ice melt and formation. Then there is water pushing into the Arctic zone from the Pacific.
We saw incredibly warm eddies coming in near Barrow Canyon, coming from the Chukchi, out of the Bering Sea, into the Beaufort Sea. And these eddies, one that we mapped in particular, was about 7 degrees warmer than the background water, centigrade. So that's something like 14 degrees Fahrenheit, which is really remarkable to see up there. So, mixing at the upper edge of this eddy, which wasn't too far below the surface, mixing all that heat up could really impact formation of ice and melting of ice.
The need for better understanding is immediate.
This year was the 4th lowest year on record since they've been collecting satellite observations for the extent of the sea ice coverage.
So this is our eddy, and what you're looking at in all of these yellow areas is warm water. So what we think this is it's water from the Alaskan coastal current. So that current comes up north through the Bering Strait and wraps around Alaska. And then these eddies can get kind of separated off of that current. And I made this circle, which is at the 5-degree line. That circle is kind of like the really warm part of the eddy.
John Mickett is focused on the eddies of warmer water detected moving into the Beaufort Sea.
And that might be one of the reasons why the Beaufort's losing ice much faster than other areas of the Arctic Ocean. Is that a mechanism like this, where you have maybe warming in the Bering Strait, the water coming in, and then you have some mechanisms that can fairly rapidly bring that heat up to the surface and affect the late summer minimum and the time at which a freeze up occurs in the fall.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.